Hi, this is Megan Poff and I'm the Field Office Chief at the USGS in Las Vegas, Nevada. During the other slope area video, we discussed the theory of the slope area method. In this video, I'll be discussing the survey requirements for the slope area indirect measurement method. You can find more information on this topic in TWRI 3-A2, Measurement of Peak Discharge by the Slope Area Method. As we learned in the last video, the field data required for a slope area measurement involves surveying the channel cross-section geometry, high watermark profiles along each bank, and then estimating roughness coefficients. First things first, though, we have to flag our high watermarks. Finding a good reach for a slope area measurement is very similar to finding a good reach for a stream gauge. You want a relatively uniform and straight reach with minimal expansion and contraction, as close as we can find for a natural stream anyway. However, for the slope area method, you also need a distance of at least 3 times and preferably 5 or more times the width of the flood channel, and there has to be at least half a foot of fall in the reach. Flag the high watermarks on both banks. If you need information on flagging high watermarks, see the high watermarks video. You will want to flag enough marks to define what the water surface profile looked like at the time of the peak. That's going to vary for every channel depending on slope, channel roughness, and the types of high watermarks you encounter. For the conditions I encounter in the southern Nevada area, I generally think, okay, less than 10 high water marks per bank isn't enough. 20 per bank might be enough, and more than that might be even better. If you aren't sure how many marks to flag, make sure you take an experienced person with you to help you out. Also see the guidelines provided on page 36 of TM 3-A24 in identifying and preserving high watermark data. Okay, we flagged our high water marks, and now it's time to survey. You can complete the slope area survey using a conventional level, total station, or with RTK or RTN GNSS if you can achieve acceptable vertical precision with these instruments. For this video, I will demonstrate how to do a simple survey with a total station. Before you leave for the field, you will need to gather the following items: tripod, prism pole or fiberglass rod, prism, total station, field notebook, site sketch forms, wooden stakes, nails, data collector if you have one along with any required cables, a cable to download the data, a field laptop, site-specific information such as a station description, and extra pencils. Remember to tape, that is, measure, your rod with the prism on it and check the collimation on your instrument and enter these data in your notes. Extendable fiberglass rods are extremely helpful for total station surveys. You can measure the extension lengths with the prism attached and record them for quick reference during the survey. Here we are in the field. The first thing I'm going to do is walk the reach and check out its extent and characteristics. This is a pretty simple reach to survey, so we're going to set the instrument up in a place where we can see the entire reach, and we'll do the entire survey from a single setup. Find or make a stable and repeatable point you can come back to just in case you need to. For this survey, we have a stable rock in the channel that we marked with a permanent marker, but you could also install a stake and set up the instrument over that. Look in the scope on the side of the total station to set up the instrument exactly over your point of reference. Tape up from that point to the line or marking that's even with the instrument eyepiece to determine the height of the instrument over the point. Record the tape up distance in your notes. We will name this point Hub 1, and we'll give it arbitrary coordinates of 1,000 feet northing, 1,000 feet easting, 100 feet elevation. If you're surveying a large site, you could also use coordinates of 5,000, 5,000. If you're surveying near the gauge, you can also reference to gauge datum. If you do decide to reference to gauge datum, tie in 2 or more gauge RMs and also survey any gauge high water marks that were flagged. Just like with any other level circuit, you will want to start your survey by taking a shot on a reference mark, 2 or more if you're starting from a stream gauge, or some other stable and repeatable point. However, remember that total stations also measure both horizontal and vertical angles along with distance. We have to tell the instrument where 0 degrees 0 minutes is located so our angles and distances will be correct. What's another name for 0 degrees 0 minutes? That's north! However, we have options. It doesn't truly matter which direction you set to 0 degrees 0 minutes because we are surveying in an arbitrary datum. You have 3 main options. 1. Set the gun 0 to true north using a compass. 2. Set the gun 0 to upstream in the channel. Or 3. Set the gun 0 to the direction of the backsight shot. I actually prefer option 3 because I can check my angle at the end of the survey very easily, but all options are valid. Focus the instrument on the prism and take the backsight. A note on accurately shooting the prism. You want to focus the total station eyepiece so the stadia lines on the gun align with the lines on the prism backplate. You can improve the precision of your backsight shots by shooting the prism direct, then rotating the instrument and inverting the telescope to shoot the prism indirect. Average the two vertical readings. We've taken our backsight, so now it's time to survey the high water marks. Instruct your rod person to tell you if they change the height of the rod, and, this is important, write down every rod height change in your notes, just in case you forget to enter the change in your gun or data collector. Survey all the high water marks on both banks to the hundredth of a foot, making sure to record any rod height changes and the composition and quality of each mark if the flaggers didn't already do that for you. The rod person or other party member can help with this documentation. Your data collector will record the point names, northings, eastings, and elevations for you, but if you don't have a data collector, you will need to record these items as well. At this point, stop and take a break. We are required to plot our high water marks in the field to identify significant breaks in the water surface profile. Remember that whole discussion about steady, uniform flow and gradually varied flow concept I covered in the theory video? Putting our cross-sections at major breaks in the water surface profile will allow us to approximate steady, uniform flow through the entire surveyed reach. Additional cross-sections can be placed in more uniform parts of the reach as appropriate, so we have an adequate number of cross-sections in the study reach. We will need at least 3 cross-sections for a slope area measurement. Placing your cross-sections correctly will result in a more reliable measurement using the slope area method. Plus, it's nice to get out of the sun for a few minutes, have some water and a snack, and collect your thoughts before continuing. You can also see if you have any glaring gaps in your water surface profile and make notes to see if you can find more high water marks to fill those gaps. I also take this time to make sure we have that required half a foot of fall in our reach. Download the data from your data collector and use a program like the SAC GUI, IRIX-SAC, or Excel to create a quick high watermark profile plot. Check out the video on data input into SAC GUI for more information. This is what a high watermark profile plot might look like for an ideal site. However, more often than not, our high watermark profile plot is going to be a messy affair. Regardless, this is what our field site gave us, so we're going to have to work with it. Let's find the breaks in slope in our profile. I usually use the edge of a piece of paper to help me with this task because most high watermark profiles can be a little messy. You usually want to give more weight to the higher, better quality marks. Let's put a cross-section close to the beginning of the reach. I'm going to disregard this area of left bank marks that appear to be going uphill, and let's focus on the rest of the profile. I'm going to place the first cross-section at RH2, then, using my piece of paper on my screen as a straight edge, let's see where the first change is. Looks like that occurs right around RH13. Our next change occurs around RH5, so I'll place a cross-section there. 3 cross-sections are our absolute minimum for a slope area survey, so I will try to add in a 4th if my reach length is long enough. Looks like we can fit a 4th cross-section around RH9 before the next potential slope change occurs. If you plot your high water marks in the field and can't detect a trend or breaks in slope, and therefore have no idea where to start, you can try displaying the left and right high water marks separately. Sometimes that will help give you a starting point to figuring out where to place the cross-sections. Great! We've now figured out where to place the cross-sections. Let's get back to our survey. We'll survey our cross-sections perpendicular to the flood channel flow to an accuracy of 1/10 of a foot. I like to use the stakeout feature in my total station controller to help find high watermark locations. This function tells me which direction to point the gun so I can quickly find the high watermark where I want to start my cross-section surveys. There's no need to survey the high watermarks again because we already shot them, although you may want to search again for marks at or near the cross-sections you selected, especially at sections where none of the marks flagged initially were close. How many points should you choose for your cross-section survey? Well, it depends. Keep in mind that your entire measurement will be based on the area that you define from this single cross-section survey, so it will be in your best interest to make the survey relatively detailed. Start and end each cross-section at points well above the high watermark elevation. You don't want to have to extrapolate your cross-section geometry later in the office. Make sure you define the major changes in the shape of the channel as your rod person moves across the cross-section, ideally left and right edge of water for each cross-section, and document any characteristics of interest. Remember to record any rod height changes. You can find more information on surveying both high watermarks and cross-sections in the High Watermarks and Cross-Sections video in this series. At the end of the survey, break the HI to turn and close the circuit by taking a final shot on your starting point. Take pictures, draw your plan view and cross-section site sketches, and estimate end values for each cross-section. You're done. You can find more information on the types of notes to record and what to put on your site sketches in the Field Notes video. If you will have a more complex survey that requires you to move the gun, see the Total Station Surveying video. If you need help in the field, call your supervisor, surface water specialist, or indirect measurement specialist.